So today we are going over derivatives of logarithmic functions. But before we do that, I think it's important to have a quick recap of what exactly are logarithmic functions or their basics and properties. Um, for example, logarithmic function log with base a times x, we call this argument, right, is equal to y, calling this as exponent, as this is simply equal to this function. So base and exponent goes at top in power, which is equal to x. For example, we have log 381 is equal to 4, which is merely equals to what? 3 multiplied 4 times is equal to 81. So this is what we mean by this log function. And then we have common log. Remember with base 10, you see this most often, log with base 10, as this is often used in mathematics, so it's also written as log x. And then we have natural log function with base e, and you will see, as this is often used, and you will mostly see this written as natural log ln times x. And then we have some properties of log functions. So log with any base, suppose we have 6 here, 1 is equal to 0. So what it entails is simply saying that as we have this logarithmic function, 6, anything raised to power 0 is equal to 1. So this could be any base, right? So it doesn't matter. It's always going to be equal to 1. And then there's another property. For example, if we have log 5, 5, like if these two are same, this is simply merely same thing, right? Following this logarithmic function definition, anything 5 raised to 1 is equal to 5. So if it could be 8, 7 here, 7 here, but this has to be same, right? Another property could be logarithmic function 5. 5 to 8 is equal to, guess what, it's 8, right? So this is another way of looking at this is like, log 5, this 5 cancels out and then you left with only 8, as this merely means same, following the same logarithmic function definition here. So 5 here, base comes here, and then the exponent goes at top, which is simply equal to argument 5 power 8. And you'll see another expression, this function of log, as this whole thing is in power 5 raised to power 5, log with base 5. For example, 12 is equal to 12. Again, what we are seeing here, same thing, right? So this is in what we call, this is what we have, this a raised to power y is equal to x. So how do we write this? Log a is 5, log with base 5, 12 here, correct, is equal to this argument is equal to log base 5, 12. And we have these laws. This is functions and some properties here and laws here. um, you know that we have three laws. Log with a means any base, a times b is merely equal to log a plus log b. And then the next is log with any base, a over b is equal to log with any base, a minus log b. And then the other law is this power one, log with base a. This is simply equals to c times power comes down in multiplication with log a. Okay. Okay, so this was a recap before we actually go over the derivatives of logarithmic functions. I hope this is helpful to recap what exactly are log functions, the properties, and this is going to be pretty handy when it comes to solve those logarithmic functions later on using derivatives. Okay, so let's go over derivatives of logarithmic functions now. We have is first we have is derivative of log with base b x is equal to 1 over x times natural log b. And then second we have that derivative of natural log x is equal to 1 over x. Third thing here we have, this has been derived from chain rule. Derivative of natural log u. I think I'm going to use the other formula, but I'm just going to write it here, whichever you want to use it. 1 over u times du over dx, or you can use this. This is the one I like to use. Natural log of this function gx is equal to derivative of gx divided by gx. 4 we have is derivative of natural log with absolute value of x is equal to 1 over x. As x cannot be equal to 0, and we have this power rule, if n is any real number. Then derivative of that function f of x is equal to n times x and minus 1. This is basically mentioned because derivative of b and n. Here b and n are both constant. So this is going to be equal to 0. So x has to be variable. Some special rules of differentiating exponential functions, like special cases, so mix up with these. This was the first case, and then Second is that derivative of this variable base with constant exponent. You're seeing the difference here versus here. Now this becomes the inner function as we have noticed before, so we have to take the derivative of that as well. So this first comes as it is, power rule times, you have to take the derivative of this function f of x in addition. And then if you have a constant base with a variable exponent, for example, derivative of constant base and then variable exponent g of x, this is going to be equal to b base raised to power gx as it is times natural log b times derivative of that variable exponent. Let's leave it to this for now and go to the next video. We are going to practice solving some of these logarithmic function derivative problems now. Thanks for watching.